Okay, last but not least, we have problems number 13. There's a request for 13 and 14. I'm just going to do 13 so that way you can try 14 on your own. We write an equation for each horizontal asymptote, which can be found in this graph, which is h of x is equal to 2e to the x minus 5 over e to the x plus 3. So horizontal asymptotes are directly connected to the limit as x approaches infinity of our function and the limit as x approaches negative infinity of our function. So we have to check out these two limits. That's why this horizontal asymptote work is on the same homework assignment as the infinite limits. They're directly connected to each other. Okay, limits as x approaches infinity and negative infinity tell us what's happening to the function as x gets really, really large and really, really small. And if we have some kind of limiting behavior, then that produces in the graph a horizontal asymptote. So the two are directly connected. So if we're interested in the limit as x approaches infinity of h of x, that means we're interested in the limit as x approaches infinity of 2e to the x minus 5 over e to the x plus 3. So we're going to plug a really large number like a billion into x. That's what we're interested in. What about a billion or a trillion or quadrillion that's going in for x? Well, that's a really, really large number. Okay. If you have e to the $1 billion, all right, you don't really care if you lose $5, you misplace it, because you have this is so powerful, this is nothing. Okay. So what ends up happening is the minus 5 in the numerator and the plus 3 in the denominator, they become inconsequential. And we have our situation where we have this huge value right here, which is also being doubled, but this huge value and this really small value. The really small value doesn't matter in the context of the problem. We can ignore it. So what we have here is 2e to the x over e to the x, right? Because, again, these are such huge numbers that the minus 5 and the plus 3 don't mean anything in the context of the problem, which is that we're taking the limit as x approaches infinity. So we have 2e to the x over e to the x. We can see that they're growing. All right, they have some similarities here. They both have the e to the x, but this numerator is double what's happening in the denominator. So that 2, that coefficient there, goes into our answer, as does the coefficient of 1 right there. Right? So we have 2 as the limit as x approaches infinity. And again, it's almost like the e to the x's wipe each other out. Okay. Well, what about the limit as x approaches negative infinity? That means we're looking at the limit as x approaches negative infinity of 2e to the x minus 5 over e to the x plus 3. Negative infinity. We talked about this on the other side of the homework. Right? Here's our graph of e to the x. And we're interested when x is approaching negative infinity. We're interested when x is approaching way over here. Well, when x is approaching negative infinity, e to the x is getting closer and closer to the x-axis, which means this e to the x is actually approaching 0. So we have 2 times 0 minus 5 in the numerator, and we have 0, because again, e to the x, here's the graph of e to the x, and we're interested when x gets really, really small way over here, and the value of the function way over here is pretty much 0, so we're going to call it 0. So e to the negative infinity is 0, but then we have the plus 3. So up here, the negative 5 and the 3 were inconsequential to finding the limit. But down here, they're extremely important, because the e sections are going towards 0. So 0 minus 5 and 0 plus 3. Negative 5/3 is also a horizontal asymptote. So we have 2 of them. And we're asked to write in the equation, all horizontal lines have the equation of y equals a number. So we're going to have y equals 2, and we're going to have y equals negative 5/3. there's our two equations of the horizontal asymptotes. Now whether it's e to the x, or 6 to the x, or 2 to the x, or whatever, the exponential functions will work in the same manner. So see if you can find the horizontal asymptotes, and there are two, for number 14 at this time.